All right, today we are going to review the real number system. Our objective is going to be to classify numbers. So recall, all real numbers can be classified into sets or sets of numbers. Although the arrows on this chart point down, the containment works from bottom up, meaning that the set above contains the set below it. So the integers contains the whole numbers contains the natural numbers. Rational versus irrational. A rational number is any decimal that stops or repeats any fraction, any integer, or whole number. An irrational number would be decimals that don't end or repeat. So they never end and they never repeat themselves. They just go on and on, different pattern forever. All right, the integers, we already talked about those a week or so ago. They contain the positive, negative, and 0. Okay, so remember we did the whole thing where we had the curly brackets. We had -3, -2, -1, 0, 1, and so on. Those were the integers. The natural numbers is just the positive integers. So the natural numbers would start with 1 and go forward. 1, 2, 3, and so on. The whole numbers would be the positive integers and 0. So we would include 0, 1, 2, 3, and so on. Another way to view the sets of real numbers is by looking at a Venn diagram. So again, any number in this diagram is a real number. It splits into two big categories, rational and irrational. Within the rational numbers, our biggest set is the integers. The next biggest set within the integers is the whole numbers. And the smallest set inside of there is the natural numbers. Which I can't even hardly fit that word in there. Okay, so we know that 14 is going to be a real number. All of these are real numbers. After we decide that it's a real number, it has to either be rational or irrational. It's got to be one or the other. Jeriel, which one's it going to be? Rational or irrational? It is going to be rational. Remember we said that rational numbers included whole numbers. This is a whole, well, see, whole number. Giving away the next part of it. Okay, after it's rational, look at that bullseye that we just filled in. Start with the biggest one and keep asking yourself, does it fit here? All right, Nevaeh, looking at that bullseye, does it fit in the outermost ring of the integers?
Yeah.
Is 14 an integer?
Yes.
Yes, it is. So we would write down integer. Okay, then we're going to go down to the next layer, the whole numbers. Mikkel, do you think this is a whole number? You got a 50-50 shot, yes or no? I guess you are correct. It is a whole number. If you need a refresher, you can go back to those number sets we just wrote on the bottom of the front page. Jaquan, our last decision, is it a natural number? Yes, it is. So it fits into all of these sets. On the number -21, Adrian, what's the most general set that this number belongs to? The big set that they all belong to. Nope, bigger than that. Bigger than that. It's on the very top of the box. Nope, above that. Real numbers. These are all real numbers. If you get called first on one of these, your answer should go real fast. Natalie, next we have to decide, is it rational or irrational?
Rational.
It is rational. The integers are all rational. Hopefully that statement makes this next part easy. Logan, what's the next classification I can give it? It's an integer. I just said that. Okay, so then we have to go down in that bullseye. We're moving down to the next smallest one. May, is this a whole number? No, it's not. So we just stop writing. We're done classifying it. It's real, it's rational, it's an integer, but it is not a whole number. And if it's not a whole number, we don't even have to bother with asking if it's natural. We're just done. Jamarl, what is the biggest set I should write for the number 9.7? Real number. Alright, after I know it's a real number, I have to decide, is it rational or irrational? Houston, what do you think? It is rational because the decimal ends. Okay, if we look back to our description of a rational number, any decimal that stops or repeats, this decimal stops. So it is a rational number. Okay, next we have to decide, is it an integer? Tariana, is it an integer?
Yes. No.
No, why is it not an integer?
Because it's a decimal.
Because it's a decimal. Integers do not include decimals. So we just are done writing, where you don't have to classify it any further. It's real, it's rational, we can stop there. On number 4, what's going to help us classify this one is if we simplify it first. Can anybody in here raise a hand and tell me what the square root of 64 is? Yes, sir. 8, very good. If you know your square numbers and your square roots, that's going to help you, especially your perfect squares. So if we're thinking about classifying the square root of 64, we're really just classifying the number 8. Okay? Jalen, what is the biggest category it belongs to? Real numbers. Ellie, is it rational or irrational?
Rational.
Wonderful. Alright, moving on down the list. Jamal, is this an integer?
Yeah.
Yes, it is. Okay, continuing on down the list. Lexi, is it a whole number?
Yeah.
It is. So finally we have to ask, is it natural? Deja, what do you think?
Yeah.
Yes, it is. It's also natural. Started running out of room. Okay, on this next set, this first one is a little tricky. I don't think I would give you this one this early in this class without a calculator and all that. If we were to change this into an improper fraction, it'd be 2 1/4 would be the mixed number, so 9/4 would be the improper fraction. Can I take the square root of 9? What number times itself is 9? 3. What number times itself is 4? Okay, so when I'm thinking about classifying this square root of 2.25, what I'm really classifying is 3/2, 3 over 2. Okay, so I wouldn't give you one this hard like on a quiz or a test without a calculator. I wouldn't expect you to have to do all that, but since we're doing it together, it's no big deal. Okay, Keon, what is the biggest set it belongs to? The real numbers. Kion, is it rational or irrational? A little louder. Rational. Very good. It's a fraction. If it can be written as a fraction, that's part of being a rational number. So we keep going down the list. Kelby, is it an integer? No, fractions are not integers. So we stop. It's real, it's rational, it doesn't go any further. On to the next one. The square root of 51. Does anybody recognize this as a perfect square number? No, because it's not. There is no number multiplied by itself, no whole number multiplied by itself that'll give us 51. Okay, if we were to type this into a calculator, it would give us some decimal that goes on and on and on and on and on. Okay, so Carl, what's the biggest set I could classify it as? It is real, yes. It's still a real number. Shannon, do you think it's going to be rational or irrational? Rational. If it's a decimal that goes on and on and on, it would be irrational. Okay, if it's going to come out, it would be 7 point something. But it would go on and on and on. Like the decimal would never end. That's how we know it would be irrational. Okay. Jakeem, what's the biggest number set for negative 2.5? Real. On all of these, that will be the most general set we could name. Time for all the names to go back in the bucket. Deja, what would we go with after that? Rational or irrational? Rational. The decimal ends, so it is rational. After that, we have to decide, is it an integer? Jamarl, what do you think? Is it an integer? No, it's not an integer because of the decimal. So we're done. Real, rational, done. Alright, we move on to number 8. Jaquan, the most broad set would be what?
Real.
The real numbers. Okay, do we know what this symbol here stands for? Pi. Good. So it's not just 3.14, right? The special thing about pi is that the decimal never ends. It keeps going. So 3.1415, I think the next one's 26, but it just keeps on going forever and ever. Okay? So, knowing that, Jamal, do we think this is rational or irrational?
Irrational.
Irrational. The decimal never ends. Any number that has pi is going to be irrational. Alright, our last group of examples. Number 9, we've got 0.23232323232323, going on and on and on. Nevaeh, what's the most general set? It's real. They're all real.
Yes, it's real.
Okay? But then we have to decide, is it rational or irrational? And if you're not sure, I would double check
Irrational?
I would double check on the front page where we talked about rational versus irrational. Natalie, what do you think?
Irrational?
I know that's tempting because it never ends, but what does it do?
Stop.
It doesn't stop, but it repeats. And remember what we said on the front. If it repeats, it is rational. The ones that don't end and don't repeat are irrational. But if we can see a clear pattern early on that continues out, then we would say it is rational. Okay, on number 10, well, I guess we should go back to number 9. I hope I don't have to ask this question, but I'm going to anyway. Jakeem, is this an integer on number 9? Is this number an integer? No, it's not. So we're done classifying it. Now we're really good to move on to number 10. Okay, number 10. Carl, what's the most broad set? Real. Jeriel, is it rational or irrational? Irrational. How'd you decide that?
Because the numbers are repeated.
Very good. It does not end, and none of these numbers are repeating in a good pattern. There is a pattern, but we don't really know what comes next. All right, on number 11, we have the square root of 27. Does anybody recognize that as a perfect square number? I would hope you don't. That is not a perfect square number. So there's no number we could multiply by itself to get 27. What that means is that this is not going to come out to be nice. It's going to equal something 5 point some decimal that keeps going on and on and on. So keeping that in mind, Ellie, what's the most broad set for this number?
Real.
A real number. May, is it rational or irrational?
Irrational.
Irrational. Which means that we can be done classifying. There's no more sets inside of irrational that we worry about. Number 12, last one. Shannon, what's the most broad set?
Real.
It's a real number. Then we have to decide rational or irrational. Jalen, what do you think? Rational. If it's a fraction, it is rational. Next, we have to decide integer, yes or no. Logan. No, it is not an integer, so that means we can be finished.